So in this specialization, we spent a lot of time up to this point talking about Arduino and its capabilities and how to use it. And now we're moving on to Raspberry Pi. Take a look at that. So let us compare the two and see how they differ. And you know, a lot of people would think that when you look at a processor or a board, you say, look, this one is just faster and better and superior. I should use that, right? Forget the old one. No, 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 no. Arduino is older, but Arduino is really well suited to certain tasks. So really, you know, I wouldn't say Raspberry Pi is superior to Arduino or Arduino is superior to Raspberry Pi. It just depends on what you want, right? They're each a different fit for what you need. Okay, so let's start off. So Raspberry Pi processor is faster. It's 900 megahertz versus 16 megahertz on the Arduino, right? So that's one advantage. It's a 32-bit processor versus 8-bit. So Raspberry Pi is 32-bit, Arduino is 8-bit. And if you remember, what we mean by 32-bit, 8-bit, when you say a processor is 32 bits, that means that the numbers that it stores inside that it works with, those are 32 bits for the most part. Now you can use smaller or bigger, but the hardware is built for 32 bits. So if you look at the adder inside, it'll add two 32-bit numbers, right? Or if you have a register that stores data, it'll store a 32-bit number, so on. So you have 32-bit versus 8-bit, which generally means that the Raspberry Pi can have a lot more resolution, a lot more accuracy than the Arduino, okay? And it can do 32-bit operations rather than 8-bit operations. So at some level, it can do things faster because it can do things more in bulk if you're clever about how you code it. So also, you can support a much bigger address space, right? If you got 32 bits, for the address space, 2 to the 32 is 2 gig. I'm slow with my math today. But that determines the size of the address space. So Raspberry Pi can support a much bigger address space. So Raspberry Pi has more memory. And by memory, there are different types of memory, right? But in all cases, Raspberry Pi has more. So if you look at the Arduino, it has 32 kilobytes of flash, where Raspberry Pi has 512 kilobytes of flash. As far as SRAM, I'm sorry, change that around. Raspberry Pi has 4 gigabytes of flash, where Arduino only has 32 kilobytes of flash. If we look at SRAM, the RAM, there's 2K of RAM in an Arduino, where there's 512K of RAM inside a Raspberry Pi. 1K of EEPROM inside an Arduino, and actually I'm not sure what the comparable number is for Raspberry Pi, but I'm sure it's big. It's much bigger. Also, the Raspberry Pi has a micro SD slot, and not to mention the USB slots, right? So if you want to, you can extend its memory by having a bigger micro SD, right, which is extra flash that you can just plug in. Or you can, and it's built in. Where Arduino, sure, you can get a shield and have a SD slot or something like that, but it's all built into the Raspberry Pi. So Raspberry Pi has a lot more memory. Raspberry Pi has lower input-output voltage levels. So Arduino, its input-output voltage levels are 5 volts, 0 to 5 volts, right? Low is 0 volts, high is 5 volts. Raspberry Pi is 3.3 volts higher, 0 to 3.3. Now, what difference does that make? That means that the Raspberry Pi is generally going to consume, or could consume, less power. Let's put it like this. A big factor in power is the voltage. In fact, the power goes with the square of the voltage, right? So the voltage is a big power consumption issue. So by reducing the power levels, you're reducing the power. Now, on the other hand, Raspberry Pi also is going to consume more power because it runs so much faster, right? It has so much higher clock frequency. So that probably more than likely offsets the power consumption issue. But going to 3.3 volts is an attempt to reduce power. So, but that needs to be kept in mind. So with the Raspberry Pi, when you interface, this will come up later at the end of this module, but also in the next module. When you interface a Raspberry Pi with different components, you got to make sure that those components are expecting 3.3 volts, not 5 volts, right? And you don't want to go the other. You don't want an external component to drive one of Raspberry Pi's pins with 5 volts when Raspberry Pi is expecting 3.3. So that can become an issue, and we'll deal with that later. Okay, so a big sort of obvious difference from a user between a Raspberry Pi and an Arduino is that the Raspberry Pi runs an operating system and the Arduino does not. Now, actually this came from an old slide. I'll just go over it again. So what is an operating system? Just to summarize really quickly. Now, we all have a knowledge of what an operating system is, right? I mean, people have used Linux and Windows and Mac OS X and so Android. These are all operating systems. But what an operating system essentially is It's a layer of software that runs on the hardware. So if you look at the picture on the left side, you got application on top of microcontroller. That's what we did with the Arduino. We wrote our application, wrote the code ourselves, and then that ran directly on the microcontroller. So you compile it, and that's what runs. So what the processor is running is exactly what you wrote, and that's it. On the other hand, the other picture there on the right side, it shows the application at the top that maybe you wrote. At the bottom, there is a microcontroller that it has to essentially run on, but there's all this software in between. There's a set of library, that whole block we'll call that's a simplified version of an operating system. This is a simplified version. We can't go into operating system class, but this is the idea. There are library functions inside there that the application can call. And we had library functions with the Arduino too, but these library functions are part of the operating system. And these library functions make system calls, which are other parts of the operating system, and those system calls are what actually interact with the microcontroller. So the application doesn't directly interact with the microcontroller. So what that means is the application can't directly change a pin, turn a pin from high to low or low to high, right? Because it's got to go through the operating system. It basically makes a request of an operating system library function, and the operating system library function decides that request is okay, and then services the request by switching the pin if it feels like it should. So there's this extra layer of software in there, the operating system, that's running. So when you run your application, it's not just your application. Your application is calling the operating system, and the operating system is doing the dirty work of dealing with the hardware. Okay? So there's this layer of software. That's an operating system. And that is enabled in a Raspberry Pi. A Raspberry Pi, you use an operating system, where an Arduino, you don't. And this is not to say that no one has ever thought of an operating system for an Arduino. Probably somebody has, but no, they're not in common use. And it's hard to imagine that you could do it given the constraints. So the fact that you have this extra layer of code, this operating system code, that requires processing power, right, that slows everything down. Because your application can't just switch an LED off and on, right? It's got to call the operating system code, which then does it, right? So there's this slowdown because you're running the operating system. Also, operating systems use a ton of memory. So suddenly you need lots of memory on your machine just because of the operating system. Even if your application doesn't require hardly any memory, even if all your application is doing is turning an LED off and on, you still need tons of memory just for the operating system, right? So that's why, a regular an Arduino can't sustain that, but a Raspberry Pi can. So Raspberry Pi, that's sort of the main obvious difference from a user, is that on Raspberry Pi you're working with an operating system, where with Arduino you really are not. You just write your code and it runs directly on the microcontroller. Now operating systems, they slow things down, they have lots of issues, but they have lots of advantages, and we will get into that over the course of the specialization, really. Into this module and into the next, we'll talk about the advantages and the benefits you get from using an operating system on a Raspberry Pi. Thank you.